My name is Muly San from NYU University. I'm on the market this year, but today I'm going to present a paper which is not my job market paper. This paper is about the impact of labor supply on technological change. I'm going to exploit a rare opportunity to study this question, which was the abrogation of the Bracero program between the United States and Mexico in the end of '64, which led to a big negative shock to the labor supply in the agricultural sector in the US, and I study how it affects the innovation of new technology in this sector. So let me start with, so my research question is whether labor scarcity increases the technological innovation. This question actually is pretty famous in economic history. So the Habakkuk hypothesis was that labor scarcity in the United States was one of the major reasons why the US became the technological leader compared to Europe. Similar arguments were claimed about other countries and periods, but actually if you think about the theoretical direction of the impact, we can think about two opposing forces. So the first force, which might be more intuitive, is that scarcity of one factor in labor, in our case, might increase the wage of this factor, and that increase the incentives of developers and technological inventors to invent technology that's going to replace this factor. So that's it's dated back to Higgs, but the UM gave the modern paper about that. But on the other hand, if we think about the market side, actually we think about the opposite effect. So if we have a larger market for one industry or for one type of product, actually the incentive to develop machines that support this the production of this factor actually is higher. So that actually, if we think about a standard growth model and we think about the steady state, so actually we usually assume that the amount of labor in steady state and the amount of capital are correlated, right? So if we have higher share of labor, it is correlated with higher capital, which we can think about a proxy for technology. So yeah, so in this paper, I'm going to study empirically what is the direction of this effect. So I use the abrogation of the Bracero program in the end of '64 to have a big negative shock to the labor supply in the US. I use variation in the exposure to the shock at the crop level. So I'm going to compare crops that were more exposed to the shock, which means that they employed higher share of Mexican workers before the end of the program, and I will compare them to crops that employed lower share of Mexican workers, so they didn't experience a big shock to the labor supply, and I could compare the technological innovation in each one of those crops. I use patent data to measure the technological innovation in crops, and what I find is a significant, large, and persistent positive effect of labor scarcity. Let me briefly describe the literature. So there is some literature about the impact of scarcity of other factors on the direction of innovation, but not of the labor supply factor. We know that labor supply increases the adoption of labor-saving technology. In this paper, I'm going to study the impact on the creation of new technology, which is maybe more interesting, and that also was the leading example of Habakkuk, for example. A recent paper by Ethan Lewis and co-authors studied the impact of the abrogation of the Bracero program on mainly on wages and employment of the local workers in the US, and they found actually no effect on employment and wages. So my paper complements their paper by suggesting direct mechanism for this. So the claim is that the reason why the employment on wages in the US didn't react to the big change in the labor supply of Mexicans is because there was a technological response that prevents wages and employment to rise. Finally, there is large literature on the impact of high-skilled immigration on technological change. So this literature study the supply side. So how much restrictions on immigration impact the available supply of inventors and scientists. So for example, let me do some self-promotion. So in a paper with my co-author Petra Moser, we study the impact of the 20s quotas in the US that restrict the immigration from Eastern Europe, and we show how it impacts the number of scientists that are available to invent new technology, and we show a big negative supply of this labor of this supply side impact. Okay, so a plan for today. I guess I first going to describe briefly the historical background and the data. Then I show the main results, the effect of labor scarcity on innovation. Then I check whether the allocation of Mexican workers to different corps is actually random. Then I add another dimension, which I can compare the effect for different technological classes and to see whether the impact is stronger for technological classes that are more labor intensive. And finally, I check what happens to the farm owners following the end of the program. Okay, so starting with some historical background of the program started in the middle of the Second World War because of a shortage in the agricultural sector in the US. In '84, the program became private, so the Bracero workers were employed directly by US farmers. In '51, the Congress approved Public Law 78, which makes the program persistent. So let me emphasize something. So during the 50s, according to historical records, the program was kind of the steady state in many US states. So it was not perceived as a temporary program. Only in the beginning of the 60s, the opposition to the program started to rise. The reasons were actually very similar to what we can do nowadays. So up to a few days ago, it was about to help local workers to find employment and to increase wages. So that's why they wanted to restrict the employment of Mexican workers in the agricultural sector. So in '62, the US government increased the wage requirements for those Bracero workers, so the program became much less attractive. And then in the end of '64, the program will terminate completely. So to measure the innovation, which is my outcome, my main outcome variable, I use patents by crops. I use both the number of patents and also I account for the quality of the patents by scale the number of patents by forward citations. I focus on technological innovations that are related to harvesting. So most of the Bracero workers worked as harvesters and in harvesting and picking. So if there is a technological response, we should expect to see it related to harvesters and related machines. So I focus on this technological class, and the way I allocate patents to a specific crop, I simply use the text of the patents and search for the names of each of the crops. So for example, I search the word tomato in the text of the patent, and if I see this word in the text of the patent and patent that's related to this technology, I allocate these patents to tomato. So I allocate it, and I know the year of the patent. My treatment variable is the exposure to the shock. So I use the share of foreign seasonal workers in '64 in each one of the crops to proxy the exposure to the program. Unfortunately, I don't have exact information on Mexican workers by crop, but it's not such a big problem because during the use of the program, about 95% of all foreign workers were Mexicans, so that's a good proxy for the exposure to the program. And my sample consists of 16 crops which use 4,000 or more man-months of foreign labor. So I already use, so my sample consists of crops that are labor intensive already, but I compare crops that rely more on Mexican workers compared to crops that rely less on Mexican workers. Okay, so first I want to check whether my simple measure of innovation by crop is makes sense. So what I do is to compare the number of patents of each one of the crops to the size of this market. So maybe the basic prediction of each technological change theory is that we might expect to see more innovation if the size of the market is greater. So we are not talking about changes in the size of the market, we just talk about the scale of each market. So this is what I found, a clear correlation between the size of each market and the number of patents for this market. Now I'm ready to study the impact of labor scarcity on innovation. So that's the raw data. I split my sample into 3 groups and plot the number of patents in each group by year. So what we can see is that, of course, with low exposure, we hardly see anything before and after the end of the Bracero program, but of course, with medium and high exposure, we can see it with our eyes, even if you don't see those lines, that exactly at 65, there is a discrete jump in the number of patents per year, and this increase persists for a few years later. So in order to check it in a more rigorous way using a regression, I run a diff and diff specification. So my main parameter of system is whether crops that were more exposed to the program before the end of the program experienced a faster technological growth after 65. And I have also crop fix effects and year fix effects. So
Ishmael, sorry, you mute yourself. So, okay.
Can you hear me now?
Yeah. Go ahead.
Sorry about that. Okay, so that's the main result. So we find that crops that were more exposed to the Bracero program experienced a faster technological growth after the end of the program. The effect is significant and also economically significant. So if we want to understand the magnitude of the effect, so increase of 1 percentage point in the foreign share before the end of the Bracero program leads to increase of about 3% in the number of patents after the end of the program. If we take into account the quality of the patents, the impact is a bit lower, but still very large. So it's increased the number of citations by about 2%. Compared to the average mean patents before 65, which were 4 patents per crop on average. So increase of 1 standard deviation in the shock leads to average response of about 2 patents. So that's about half of the patents per year. So that's a big effect. That's the event study graph. So we see, so despite the noise that we have, we see no clear trend before before the termination of the program. But we see after 65, we see persistent and significant impact in on the number of patents per year. So I did a bunch of robustness checks, but I don't have time to show them. So I check the robustness to the definition of the treatment, to the allocation, to the algorithm that allocate the patents into the different crops. For example, in the baseline specification, I use the first crops that mentioned in each patent. But for example, if you have a patent that mentioned more than 1 crop, you can decide to allocate the patents to the crop with the highest mention, so to each one of them. So I did many alternatives, and the results are robust to each of them. I extend the crop sample to include other crops that I have some partial data on them, and the results are robust. And also I changed the use of the analysis. Okay, now I want to check whether the allocation of the exposure is indeed random. So I'm doing that in two ways. First, I'm using a standard IV approach. So I proxy the allocation or the exposure of each crop by the share of Mexicans in each crop and by the distance, the average distance from Mexico. That's the first way I'm doing that. And the second, I'm using the technical properties of each crop, and I check whether the technical properties can predict what's going to be the exposure, and I show that there is no correlation between the two. Okay, so starting with the IV approach, I use two maybe trivial IVs to predict the number of Mexican workers in each one of the crops, which are the distance from Mexico and the historical Mexican population. In order to write our regressions are in the level of the crop, so we need to transform the data from the spatial level to the crop level. So what I'm using the agricultural census, and I take how much what is the share of this crop in each one of the counties. So if you have counties, for example, that is growing more tomatoes, and we know that this county is closer to Mexico, so the measure for the distance from Mexico for tomatoes will be higher. So that's so I build these IV measures, and again, now I run this IV specification, and I run it separately for each one of the IVs and for both of them together, and I get impacts of about the same size, maybe a bit larger actually. The second way to check whether the allocation of the exposure were random, I check whether the exposure can be explained by technical properties of the crops. So if that would be the case, and we think about some different dynamics for different crops in different stages of development, it might be problematic for my results. So what I'm doing is to build a set of similarity metrics. Again, I'm using the patterns data, and now I use patterns that mention more than one crops. And the idea is that, let's say you have a pattern that mention both both apples and oranges. That means that this harvester, for example, is capable of harvesting or help to harvest both apples and oranges. So it means that there is some similarity in the technical properties of those two crops. And this similarity actually is the relevant one. So the similarity with regards to harvesting properties. So I'm doing that systematically. I build for each one of the crops, I'm checking what are the crops that are most similar to it in terms of the harvesting properties. And I predict what would be the foreign share of each one of those crops based on the foreign share of the crops that are similar to these crops. And what I found first that there is no correlation between the actual foreign share and the predicted foreign share based on the technical properties of the crop, which again suggests that the allocation of Mexican workers to the different crops is orthogonal to technical properties that related to harvesting. I'm showing that in another way. I add both of the actual and synthetic foreign share into the regression, and I show that only the actual foreign share is explaining the changes in patenting. Okay, next what I'm doing is add another dimension. So now I'm running triple difference regression, and I'm checking whether the effect is stronger for technological classes that are more labor intensive for each one of the crops. So we can think about two interpretations of this regression. First, we can think about it as another robustness check. So we can think, for example, assume there is some demand shock for one crop. There is demand shock that is somehow correlated with exposure to the shock for some reason. So what this robustness check is doing is to conform for that. So you compare within much of the crop. So I have yield and crop fixed effects, and we check whether technological classes that are more labor intensive have higher technological growth after the shock. That's the first interpretation. The second might be even more interesting, but is also more suggestive, is that we can think about it as testing another hypothesis, which is, so if we in the paper I build a simple theoretical model that shows that that for technological classes that are more labor saving, the impact should be greater compared to technological classes that tend to be more labor augmenting. So if we think about technology in some crop or tasks that tend to be more labor replacing, the impact of labor scarcity on the direction of the technological growth on this crop and task should be greater compared to technologicals that are more labor augmenting. So if we think about labor intensity as a measure of this labor saving of this task, for example, if we think, so in my data, harvesting again is the most labor intensive task. So if we think that technologies that are related to harvesting also tend to be more labor saving, so that's going to suggest that this hypothesis is also true. So the impact of labor scarcity is greater for classes that are more labor saving. I hope it's clear. So what I do in practice, I went to the Department of Labor in the US, to the archives, and I use archival data on the labor requirement by task and crop. So for each crop, there is a long list of all the tasks that are related to this crop, and for each task there is how many man months are needed for acre, and what is the cost of the labor that needed for each acre. And using this information, I build a cost table that map the different tasks into the different patent classes or technological classes. So I build a labor intensity of each one of the crop and by task. So, and then I can run this triple diff specification. So now I'm interested whether the impact of labor scarcity is greater for technological classes that are more labor intensive for this crop. So for example, if there is, in tomatoes, there is higher requirement, you need more labor to harvest the tomatoes compared to other crops, the question whether the effect is stronger for this technological class in tomatoes. So now I can control for each one of the two-way fixed effects. So I can control for crop class, crop year, and class year fixed effects. So that's what I found. So again, I found the effects that are very similar in magnitude to the baseline effects that I found before. So I'm doing that in three ways. I'm using the labor intensity, so the amount of labor that needed for each task. I'm using the cost of each unit of labor. And also I'm using simply classes, the average labor requirement for each class. That's a third row. And I get similar results for each one of those specifications. Okay, the final thing that I want to check, I want to show in this talk, maybe I have a lot of time, so maybe I'm going to finish earlier than expected, is what happens to the farm values in the counties that were more exposed to the shock. So Clements and co-authors and show that the workers, the US local workers, actually didn't gain anything from the termination of the program. It might be interesting to check what happened to the farm owners. So whether they gained from this, the end of the Bracero program. So in order to check that, what I do is I use, again, the agricultural census and build a measure of the exposure of the program for each one of the counties. So now I'm doing the inverse transformation. So now I'm build exposure measure for each one of the counties based on the exposure measure of each one of the crops. And again, I'm using the share of acreage of each crop by county. So I build a measure of the exposure of each county to the Bracero program, and I check what happens to the land values after the termination of the program. So again, I'm running this DD specification, and I'm doing it separately for Bracero and non-Bracero states. So there are states that didn't use Bracero workers at all. So we would expect to see nothing in those states, and there are states that employed Bracero workers, and for them, we want to see what happened to the land values. So that's the result. So the upper panel is the impact on the Bracero states. So what we can see is that right after the end of the program, the land values in the Bracero states decreased significantly. So that means that even though the technological response was positive, the impact on the land owners was so negative that they lose a lot from losing the Bracero workers, which makes sense, right? So if we remember that the main opposition for the termination of the program were by farm owners that enjoy for employing cheap labor. So yeah, so we might expect that we're going to see a negative impact on the land values of those farmers, and we see hardly not effect for states that didn't employ Braceros at all. So yeah, so we can conclude that this support against the claim that the termination of the program was non-desirable for the farm owners and was non-expected. So we see drop only after the end of the program. Yeah, and we don't see a technological response that compensates this decrease in the land values. Yeah, so that's all. Thank you very much. I will be glad. Yeah, I guess question hour later, right?
Yes, question later. Now Ethan can step in. You can unshare the screen, Shmuel.
Sure. Yeah.
All right. Well, that was a great presentation, Muly.
Thank you.
And I think this is a wonderful paper. I'll just preview that before I get into the details here. I mean, the fact that this is this is not his job market paper. This is his other paper. I mean, this is incredible. So I think this is a major contribution, studying the impact of the kind of end of the Bracero program on innovation. I'll explain why I think that. And